Hi, in this video I will talk about case 4. Case 4 Case 4 of portfolio theory. Remember, case 4 is, just remind you, this is where the losses x1 to xn are INID, which means that independent but not identical, and n is the number of investments, is a random variable, and we must assume that independent of x1, x2, etc. So n is independent of this, otherwise we can't do the calculations. So the first variable I'm going to look at is the total portfolio loss. So we can write this as the CDF. We can write the CD by definition is the probability. Capital S is less than equal to little s. And in the next line, I'm going to use the total probability rule, which I mentioned before. So this is the total probability rule, which says that this probability is equal to the sum of the conditional probability of S given n equal to little n. So you're fixing the value for the number of investments times the probability that capital N equal to little n. So this is the total probability rule. Okay. Now, in the next line, I'm gonna, because this is a conditional probability of S given that capital N is a fixed number, we can use the result of case 3. Because remember, in case 3, the number of investments was fixed. So I'm going to use, what I'm going to do is I'm going to replace the conditional probability by what we got, the formula that we got for the distribution function of S in case 3. Right, so this is the formula. You should recall, this is the formula that we got for the CDF of S in case 3. And this multiplied by the probability. Okay. So just to remind you that in this step I have used the result of case 3. Okay. Right. So that's the CDF, and the PDF Alright, that's the PDF of S. The next variable is U, So the CDF is, you can write it like this is the notation. And by definition is the probability that capital U is less than or equal to little u. And using the total probability rule, you can write this as the sum of the conditional probability given capital N is a fixed number times the probability that capital N is a fixed number. So I have used, once again, the total probability rule. Okay. Now in the next line I'm going to replace the conditional probability by the result that we got under case 3, which is the following. Right, multiplied by the probability that capital N equal to little n. Now here you have two terms, one minus something, so you can separate it out into two sums. The first sum being the sum of the probabilities, okay, and the second sum being okay, and the sum of the probabilities must be 1 by definition. So this is 1 minus the sum right. Okay, so this is the formula for the CDF of U under case 4. Now the PDF of U is you just differentiate this with respect to U using the product rule I mentioned earlier. Okay, so if you do that, you will get the following. So if you differentiate this with respect to U, you will get sum I from 1 to n little f xi U product j from 1 to n j not equal to I times the probability that capital N equal to little n. Alright, so this is the, so once again I have, in this step here I have used, just to remind you, I have used the product rule I mentioned earlier, right? Okay. Right. So that's variable U, and finally the variable V is the Okay, this is the notation, and this follows by the definition. And now I'm going to use the total probability rule, and I'm going to write this as a sum of the conditional probability of V multiplied by this. Right. Now, in the next step, I'm going to replace the conditional probability by the result that we got in case 3. So this is, if you recall, this is the result that we got in case 3. All right. So this step here follows by case 3. Right. So that's the formula for CDF of V under case 4. Now the PDF of V under case 4 is as follows. Right. So once again, I'm going to use the product rule I mentioned earlier. So you will get the following. You get sum n from 1 to infinity, sum I from 1 to infinity, product from j from 1 to n, j not equal to I, okay, times the probability that capital N equal to little n. So this follows by one of the product rules I mentioned earlier. All right, so this completes case 4 of portfolio theory, and the two remaining cases are case 5 and case 6. But before I can talk about them, I need to introduce some terminology. All right. So in the next video, I will talk about some terminology that we will need for case 5 and 6.